G'day traders, welcome back to another video on our favorite language, Pine Script. In today's video, we're going to be dealing with a subject that's not particularly sexy, but it is very important for us to understand. And that is the subject of debugging our scripts. For those who aren't aware of the term debugging, it basically just means looking under the hood of our script and seeing what the script is actually doing. For example, if we're working with a for loop and our script is giving us incorrect output, then we may want to look inside the for loop and see what each loop is doing. And that's what I have on my chart here. We have two labels here that is essentially debugging a for loop. Now, there are multiple ways to debug our scripts. There are multiple reasons why we might want to. And in today's lesson, we're going to cover all of those. But before we do that, I just want to really quickly make you guys aware of our free weekly newsletter that I send out every Wednesday, where I share a technique, a book, a podcast, a YouTube channel, a Himalayan chant, anything that I found to help with my own trading. There's no catch, no strings attached. It's completely free. In fact, this week, I'm even giving away a free book. In this week's newsletter number 10, which I haven't sent out yet as of recording this, I'm covering the book Pitbull, which is one of the best trading books I've ever read. And I love it so much that I want to make sure that at least one person out there gets their hands on it. So I'm going to send a free copy to a random person who opens the email. So if you're interested in that and you want to get more insight into where I get my information from and the types of people and information sources I allow to inform my own trading process as a consistently profitable trader, then go to theartoftrading.com, where you'll find links to all my social media and courses, blog, podcast, Pine Script forum, all my TradingView scripts, and at the bottom here, you can sign up to the email newsletter if that's something you're interested in. With that out of the way, let's get into today's lesson. All right, so to get started, here I just have a simple script that's plotting the closing price of the market that we're on. The market is irrelevant, but we're on Bitcoin for now. And we're plotting a horizontal line at 20,000. This is just to set the chart scale, and I'll explain why in a moment. So I open up my code. Here we're just plotting the closing price, and we're giving the plot a title. You could also specify this. But if you're not aware, in Pine Script, you need to put the parameters in order of their appearance in the documentation. So the first thing we're plotting is a series. In this case, it's the closing price series. The second parameter is a title. So I can have a string title here. The third parameter is a color. So if I put them in order, I don't need to specify what the parameter is. But if they're not in order, like this, then the script won't compile, because these parameters are not in the correct position. And so what I would need to do here, if I wanted to put the parameters in any order, I need to specify what the parameters are. So we have a plot here that's plotting the closing price, color of blue, and the title closing price. So now, if I come up to the data window, which is this button here, and I click on that, here is the date and time of the market we're on. Here is the market's price data, volume, and open, high, low, close. And then here is our script that we've added to the chart. So this data window will list all of the indicators you have added to your chart. And when we're developing a script, this is where we can start to debug our values. So if I hover my mouse over past bars here, you'll see this closing price data value updating. So this is the first introduction to debugging your scripts. Obviously, you can also just look at the plot here, but if you've got several plots drawing out on your indicator, it can get really confusing knowing which one's which. So that's where the data window comes in handy. We can see the title of each value that we're drawing. So now that we have our chart scale set, let's create some debugging values, some values we can work with. So for today's video, I'm going to just work with volume, average volume. So what we're doing here is we're getting the average volume over the past 50 bars using an SMA, a simple moving average or smooth moving average. So we're calculating the 50 period SMA of volume, and that gives us our average volume. Then we have a Boolean value here, a true-false value, that checks if the current bar's volume is greater than the average volume over the past 50 bars. So now if we wanted to debug the raised volume Boolean value and see if it's true or false on each bar on our chart, we can use the plot function for this. However, if I just try to plot raised volume as a plot like this, my script won't compile because this is a Boolean value, not a number, and plot can only plot numbers. So what we would need to do here instead is use a conditional operator. So we can say, is raised volume true? Question mark. If so, plot 1. Otherwise, plot 0. Now when I save my script, we'll be getting 1s and 0s drawing up here to let us know whether or not volume is raised above the moving average. I can also title this raised volume. And now this plot is showing up in my data window. However, if I minimize this script, you can see that our chart scaling is now all screwed up. So we're plotting 0 and 1 all the way down here, we're also plotting the price value. And because we're plotting 1 or 0, the chart will automatically scale to show all the plots in your script. And so that screws up our chart scaling. The way we can get around this and still plot this 1 and 0 debug value to the data window is using the Plotchar function, or char, plot character. This is short for plot character to the chart. And it's similar to the plot function in that it takes a series. However, it also takes a character. And so what we can do here is I can just get rid of title. Since we're inputting all these parameters in order, I can plot our series, our title. The character is just going to be blank, and we can leave it as that. And if I save my code, the chart scale here will be corrected. See, now it is automatically scaling because I'm on auto here. But if you look really closely, it's hard to see, but there's these little blue dots all over the place. Those are our plot character functions plotting a blank character. I don't know why it plots a dot instead of a blank character, which is what we wanted, but it's an easy thing to fix. All we need to do is specify the color of our Plotchar function, and it doesn't matter what color you set this to because we're going to set the color's transparency to 100%. So I could set this to color.new, color.red, 100. And now what you'll see is this number here will turn red, and all of those little blue dots on my chart will disappear. So keep an eye on these two things. There we go. Our raised volume is now red, and we are not getting anything drawing onto the chart. You can do the same thing with regular plots, but again, remember that will screw up your chart scaling in many circumstances. So that's one way to debug Boolean values. Another way, my preferred method when I'm developing a script, just because it's really quick and easy, and I'm a very visual trader, so just staring at a bunch of numbers will often just make my brain switch off. So I like to use things like changing the background color of my chart based on a condition when I'm developing my script. Once I've built my script, maybe I'll change that background color into a plot shape, something that looks a little bit better, a little bit more tidy. But when I'm developing and I want to get my code written quickly, I'll just use the BG color function to check, is raised volume true? If so, set the background color of my chart to color.green with 50% transparency. Otherwise, set my background color to nothing. Now, if I save my code, I can close the data window and I can just see when volume is raised by this background color here. Now it looks terrible, obviously, so when you finish your script, as I said, you might want to turn this into a plot shape function that draws boxes at the bottom of your indicator or something like that. But for now, this will do. It's a very quick method for debugging, particularly market conditions and just general true-false values. So that's the beginning of debugging. Now, the next thing I was going to show you, which I already have shown you, is the Plotchar difference. So let me copy some code over here and explain what's happening. Displaying data in the data window is achieved using plots. So plots do work. Plot shapes also work. That will show up in the data window. However, the preferred option is Plotchar, as I mentioned, because it will not affect your chart scale. So now if I save my code, we won't be drawing raised volume anymore, but now we're plotting our average volume. So we can actually see what our average volume is. And if I copy this code and paste underneath here volume, and I can say current volume, now we can compare the average volume to the current volume. And so if you look at when I hover over a green bar, current volume is going to be higher than average volume. That's the condition that sets our background color of our chart to green. But just to reiterate, for those who are new to Pine Script, if I were to plot the number 1 onto my chart, that's going to jack up my chart scaling, because now we're plotting 1 all the way up to the current market price, which is 22,000. So the correct method is to use Plotchar. So that covers the majority of circumstances where you might want to debug your script. Obviously, this is a super simple script, but if you're working with dozens of different values, you can use the Plotchar function to see what they're all doing and sort of break down the inner workings of your script and see under the hood, see what all of your variables are by hovering over each bar on your chart, and you can double check and confirm that your script is doing what you think it's doing. However, when we're working with for loops, things get a little bit more complicated, because if I write out a simple for loop here, we can't say Plotchar the current bar's volume in our for loop. Say volume with a blank character. If I save my code here, we're going to get an error because we cannot use any plot functions inside a local scope. So that means we cannot use it in an if statement. Anything that's tabbed, this is a local scope. of our for loop, we cannot use any plots, anything to draw to the chart inside a scope. So we can't draw in for loops, we can't draw in if statements, we can't draw in functions. We can only draw in the main scope of our script. So if we want to see what our for loop is doing on each loop, things are a little bit more complicated. For today's example, to keep things really simple, let's just add up the bar size of the past 10 bars. Technically, this would be the past 11 bars because we're starting from 0, counting up to 10. If we wanted to do the past 10 bars, this would be 0 to 9, and that would start counting from the current bar 0 back 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which would be 10 bars. So I'll leave it as that for now. Let's count back the past 10 bars. And what we're going to do is we're going to add up the total bar size over that look back period. To do that, I just need to add or update the total bar size to whatever its current value is on this current loop, plus the current bar's high, the current bar in our loop. So I is the bar index of our loop. So the high minus the low of this current loop. And then I can use a Plotchar to plot what our total bar size is. So now if I save my code, this is incorrect. Let me change that to total bar size. So now we can see that the total bar size, adding up the bar size of the past 10 bars on our chart, gives us 2,632. And now if I were to divide this number by 10, that would give us the average bar size over the past 10 bars. Let's do that next. I can say average bar size equals total bar size divided by 10. Now, if I wanted to turn this into a user input, I could say loop length equals input dot integer look back. We'll give it a default value of 10. And I've been getting into a new habit of declaring what my data type is when I declare a variable. You don't have to do this. Pine Script will automatically detect what type of what data type you're working with. But I've started to do this because with the new latest Pine editor, the color coding, it makes it a lot easier to read your code and see what each variable is. So anyway, here's our loop length. When we're looping, remember 0 counts as 1. So what we need to do here is subtract 1 from our look back length. And then when I'm dividing my average bar size, I need to paste that loop length in there without subtracting 1 from it. And now we're looping from 0 to 9, technically 10 bars, and then dividing the total bar size by our look back length. Now if I save my code, well, actually I forgot to plot this, hang on. Let's plot the average bar size. I'll put this under our bar size. I think that'll make it more intuitive to read the data window. So now when my script compiles, we have the total bar size over the past 10 bars, and we have the average bar size over those 10 bars. And if I wanted to, I could also add in our look back length and paste that in there. And so now all these red numbers are showing us our look back period, the total bar size over that look back period, and the average bar size over that look back period. However, what if we were doing something more complicated within this for loop and our script was giving incorrect output and we didn't know why? That's where debugging the for loop comes into play. And the best way to do this, there are multiple ways. You could create an array and you could feed each value into the array and plot them all individually using Plotchars. That's an option, but it's a little bit convoluted. My preferred option is to simply do what's referred to as building a string. So we can build a string of text that adds the for loop values to the text. And then at the end of our for loop, we can draw a label onto our chart that shows what happened within the for loop during each loop. So to do that, I'm going to create a new variable here called string debug string. And it's going to start out as just a blank string with nothing in it. And then what we're going to do is we're going to build our string. So the same way we add up our total bar size by assigning total bar size to total bar size plus the latest loop value, we do the same thing with our debug string. So we're going to set debug string to whatever it currently is, plus, and then I'm going to, this is going to get a little bit complicated to read, but it's really quite simple. What we're going to do here is we're going to open a square bracket and then add the current loop index I to this string so that we know what this string is referring to. But remember, when we're dealing with Pine Script, we cannot add a number to a string directly. We need to use the str.toString function to convert the number into text so that our script will compile. And now if I close that bracket off and I add a \n. This \n will create a new line. And then when we draw this string onto a label, each loop value will be on its own line and it'll make it easier to read. So now that we have our debug string, we'll expand on this in a moment, but just so that we are all on the same page, let's first simply draw this debug string to the chart using a label. So to do that, I'm going to check if the current bar state is the last bar on my chart. If I don't do this and we just draw a label on every bar, then we'll have labels all over the place and it will be really hard to read. So what we want to do is only draw the label on the final bar, and then we can debug the latest 10 bars to make sure that our script is doing what we hope it is. So to create a new label, I can say label.new, and then we need to pass in the bar index and a price value. So for this label, I'll set it to the current bar's high. Now we need to specify the text for the label. That's just going to be our debug string. And I'm also going to set the color to color.black and the text color to color.white. And one final thing I'm going to do to make our label easier to read is set the text align to left, because I think by default it's centered. And so if we have an inconsistent string length, it'll center everything and it's just not ideal. We want everything to be aligned to the left. That'll make it easy to read. So I can set text align equals text.align left. And let's hide the data window so we can see more code here. So now when I save my code, keep an eye on this label here. There we have it. So we are now building a string, and each string starts with the loop index. And then what we can do here is we can start adding values from within our loop. So for example, we could say here, total bar size equals plus str.toString total bar size. And then I need to finish that string. And now if I save my code, we'll be getting more information on this label. There we go. So on the very first loop, on the very first bar in our chart, the total bar size is 155. And we can verify that by measuring the bar. And close enough, 155. So this is an accurate value. Then we can check loop number 1, which is this next bar back. The bar size there is 312. So now if I measure from the high down to the low, 155 plus 169 is approximately 312. So remember, we're adding up the bar sizes as we loop back. If we wanted to see what the bar size of each bar is on our loop, we need to change our code a little bit here. And to make this easier to read, this isn't necessary. You can just keep writing the string off the screen if you want to, but since I'm doing this for YouTube, I'm going to start a new line here. And to start a new line when you're dealing with a single expression in Pine Script, this here is an expression. If I want to extend this expression to multiple lines, then I need to press enter here, then tab, and then 1 space. I don't know why, but that's how Pine Script works. If I don't have this space here, my script will not compile. But if I add a space after that tab, it will compile. I think you can also just have 1 space here. That works too. So whatever makes more sense to you. Personally, I find the tab in 1 space makes more sense to me because it's more obvious that I'm extending this line. Sometimes it might be hard to see this single space, but it's just a matter of preference. Just make sure that you have 1 space after you start your new line and you're at least on the same scope as our expression. So now what I can do is I'll actually bring this one back and we'll start a new string here. We need to have a space here because otherwise this will add on to the end of this number. So 1 space, and then I can say bar size equals, and then str.toString high minus low of our current loop. And then now if I save my code, we should be getting more information. So now it's showing the bar size of each bar as we loop back. And it's showing the total bar size as that is being accumulated. So you can see now how this can really help us get an insight into what our for loops are doing. And that's really it. I mean, we could add more information here if we want to. So for example, I could start a third line here and I could specify or display the current bar's high price and the current bar's low price. And when I say current bar, I mean the current bar in our loop. So when I save my code now, we're getting a lot more information. We're getting the total bar size, the current bar's high, the current bar is low, and the corresponding loop index for that information. And so now we can double check that our script is actually working with the same data that we want it to, and it's outputting the correct information. And that's it. That's really it for Pine Script debugging. Unfortunately, there's no better way to do this sort of thing. I wish the data window had an option for plotting things that do not draw onto your indicator values. Any plots, even Plotchars that are blank and aren't drawn onto your indicator, will have a number here in the indicator values list. I wish there was a way to hide these so that you could only see them in the data window. That would make some scripts a lot tidier, especially ones that have tons of plots, like my ultimate pullback indicator that I showed you guys in the previous video. That has tons of plots, and these numbers just go off the chart, and it just clutters up your screen. Obviously, you can come into the settings menu and you can turn off indicator values, and then they're all gone. But sometimes you want to know what those indicator values are without opening the data window. But anyway, I digress. I also wish there was a way to send text directly to the console here. That would make things so much easier for us as Pine scripters. If we could just say print and then some sort of text, and that would come into the console. That would be a super useful feature in Pine Script, but unfortunately, for whatever reason, we do not have that capability yet. And so the next best thing is just using labels. And so before I wrap up this lesson, let's first of all set overlay to true here, and I'll remove this script and add it back to my chart so that we're drawing over actual price action. And the final thing I want to show you guys is how to debug a specific bar. So this is debugging the latest bar, the last bar on our chart. But what if we wanted to go back around here somewhere and analyze this bar here? Well, there is one method for doing this that is pretty convenient, and that is using a user input that sets a bar time. And then if you set that user input to confirm, I'll show you what that means in a moment. If confirm is true on that user input, then you can click on the bar itself and tell your script where to start drawing something like a label from. So to wrap up this lesson, let me show you how to do this. I'll just paste over some code to save time. So this time we're using a confirm time input to display a label on the selected bar. So we're getting an integer bar time, which is a Unix timestamp. You don't need to know what that means, but it's basically just a timestamp. It allows you to specify a time as an integer, simple integer, that will tell our script where we want to draw something. So in this case, we're using the input.time function. The default value will be -1, and we have set confirm equals true. And what this will mean is when we add the script to our chart for the first time, we will need to use our mouse to select a bar. So now I can pretty much copy this line of code here to check if we're on the last bar on our chart. And then I can say, and bar time is not equal to -1. That means that the user has selected a bar time. If a user has selected a bar time, then we want to draw our label on the selected bar. So to do that, we just need to change our bar index to bar time. However, we also need to inform or tell the label function that we are working with bar time and not a bar index. So by default, the label function, the X value, the first value in this label function, is a bar index. So the very first bar in our chart will be bar index 0, and then the latest bar in our chart will be however many bars are drawing on our chart. In this case, we don't want to use bar indexes or indices. We want to use bar time. So to do that, I need to tell my label function that the xlock value is supposed to be xlock.bar time instead of bar index. So we're overriding the default value for xlock from bar index to bar time. We're getting the bar time as a user input. The user must select the bar with their mouse. And then if we're on the final bar on our chart and the user has selected a bar time, then we'll draw a new label on that bar. I can save my code here. Now nothing's going to change because we've already added this script to our chart. So when I come up to the settings menu and go to input, the select bar input is going to be set to the default value, which is 1970, the 1st of January 1970, which is when the Unix timestamp begins calculating from. But again, that's not information you need to know about. What you do need to know is that if you want to be able to just select a bar without coming in here and setting your year and date and time and all of that, which is annoying and clunky, what we want to do is remove our script from our chart and then add it back onto the chart. And now you'll see this pop up. Select the select bar time for this script. So my script is named after my website, but here would be your script title. And now you'll see that my script has a vertical line, and whichever bar I click on will be the bar that we draw our label on. So you can hold Control or Command on a Mac to tell Pine Script where you want to zoom in. So if I hold down Control and I go all the way back, let's do a bar in here. Let's do this, this top bar here. When I click on this bar, like so, we are getting a label drawing. Now the label is all the way down here. I'm not exactly sure why that's happening. It should be drawing on the bar's high. So maybe I need to specify my ylock value here. Ylock dot above bar. Let's try that. Save my code. There we go. That's better. So now the label is drawing above the bar that I selected, which was this swing high bar here. And we're getting our for loop data drawing into a label over the past 10 bars starting from this bar. And we can do our debugging across those bars to make sure and confirm that all of these values here are accurate. I should mention that you can also debug custom functions as well. In order to do that, this is a custom function defined. The very last line in your function is what the function returns. And so if you wanted to debug what your custom function is doing, you could do something like this. Test2 and test1. So test1 is going to be a local variable created within our custom function, and it's going to be set to this value that's inputted into our custom function times 2.5. And then test2 is going to be this same value times 4. And now if I create a new value here called custom fun is set to fn, let's set it to 1. That way we can very easily see that this value is 2.5 and this value is 4. And now if I Plotchar our custom function value and I give it a title, let's just title it custom function number 1. And I save my code and open the data window. You'll notice that this number here is 4. So what's happening is our custom function is doing whatever it does here, executing this code, and then the function outputs the final line of code here. So whatever this final line of code is the function's output. So in this case, that's test times 4. So what if we wanted to multiply test2 by test1? So test1 multiplied by 4. Let me save my code now. Keep an eye on this number. That should be 2.5 times 4, which gives us 10. But what if we wanted to know what test1 was inside of our function? This is where things get a bit complicated. Those of you in the mastery course will probably be more familiar with custom functions as we cover a whole module in there on this subject, as well as what I'm about to show you, which is tuples. So if your head is spinning right now, don't worry, that's normal. This stuff is a bit complicated. It takes a while to wrap your head around. But basically what we need to do with our custom function is return 2 values. To do that, we use the square brackets, and I can put test1 and test2 in here. And now this line of code will not compile because we're returning a tuple. This function is returning 2 values now. So what we would need to do here is open some square brackets, and we need to specify the 2 values from our function. And now I actually need to get rid of this data type because Pine Script will automatically detect what these 2 values should be. And so our function is now outputting 2 values, test1 and test2. And if I want to plot the first value, that'll be this value here. So custom fun1. And if I paste this down here and change this to 2 and that to 2, save my code, we'll now be getting 2 values down here. The first one is test1, which is going to be this value times 2.5. And the second value here is going to be test2, which is test1 multiplied by 4, which gives us 10. So hopefully that makes sense. If it doesn't, just rewatch this last part of the video a few times and eventually it will click. So that'll do for today's video. I'll leave the source code to this below, a link to the source code below for those of you who want to dive into the code and actually play around with it yourself. I know this lesson wasn't as exciting as some of our other lessons creating strategies and indicators and tools, but this is an important subject that I get asked about pretty often, and it's something we all need to be aware of as Pine scripters. There will come times when your script is not doing what you want it to do, and depending on the complexity of your script, that can be a little difficult to pin down what's going wrong. These are a few methods you can use to figure that out. With all that said, I'll leave this video here. Thanks for watching as always. Make sure to subscribe if you haven't already, because I'll be back real soon with a new PineScript video. If you want to level up your PineScripting, make sure to check out our courses at pinescriptmastery.com. There's a free basics course there with several hours of content for those of you who are new to PineScript. If this lesson went way over your head, then you might want to start there. But anyway, thanks for watching. I love you guys. Best of luck with your trading, and I'll speak with you soon. Take care.